So right now, your guys' work is going to start off with, we're going to start off with 1 through 4 in your workbook. These are questions you should already know how to answer. I felt like factoring was mainly a part of last module, but they decided, that was weird. They decided to, uh-oh. Lag caused errors. They're trying to slow me down. So in taking a look at number 1, how are we going to, what technique are we going to use to factor number 1? Grouping, thank you. I don't want to just hear Holly, folks. I'm going to call on people randomly through this because we should know how to do it. So, Holly, why are we going to use grouping? There are 4 terms. Fantastic. So, number 1, 4x cubed plus x squared minus 4x minus 1 equals 0. So, we are going to solve these out. So, let's go ahead and start. Kaya, grouping the first 2. What can I factor out of the first 2? Can't do 4. X, how many of them? She's right. Squared. Okay, if I factor out x squared, I've taken 2 x's out, so I've got 4x left over here, plus 1. Kaylee, what will I factor out of the second set? Close. Negative 1, because I want to change that to a positive. Kaya? I took 2 x's out of this, and this has 3, so now they're just get down to 1x. Okay. Sione? No, you can't take it today. Today's a fast note day. You're going to have to find some other day, time to do it. Yes. Hopefully. Maybe. Okay. All right. Savannah, what can I pull out of both of those? 4x plus 1. This will be left with x squared. And this one will be left with negative 1. Gabriela, however, I can factor that. What is this? What is that? So, and when you subtract things, what do you get? You find the what? Sum is when you add things. When you subtract things, you find the difference. So if I have a square and difference, what do you think I have here? What rule do I have? Difference of 2 squares. So I'll factor it using difference of 2 squares. Okay. Each one's equal to 0. Here's where I warned you in the past. You know, if you guys have stuck it in your heads that you just do opposite signs, and I warned you that's not always the way to think. So each one of these parentheses is equal to 0. Each parentheses is equal to 0 since the whole thing was equal to 0. So here, x equals 1. X equals negative 1 over 4, but yes. Because I'll subtract 1, then divide by 4. So that's my solution for number 1. Questions on what I did? That's a statement, Isaac? Mia? Huh? Right here? Yes. So, All steps involved. No, this is just adding 1, subtracting 1 to the other side. And moving on in. Okay. Number 2. I'm going to have to factor trinomial. Let's see, Richard, what can I factor out of each of the terms in that number 2? Need to speak loud. Richard? X cubed. Factor out x cubed. I told you guys, when you've got a trinomial, it's very nice when your a value is 1, because you just have to worry about what multiplies to the end and adds to the middle. What multiplies to negative 24, which means a positive and a negative, okay, multiplies to negative 24 and adds to negative 2. Okay? When you're factoring, what multiplies to negative 24 and adds to negative 2? Multiplies to negative 24, adds to negative 2. Isaac? 6 and 4, which one will be negative? The 6. Why will it be the 6, Isaac? Other way around? Because 4 minus 6 is negative 2. So those two numbers multiply to negative 24. Those two numbers add to negative 2. Destiny.
So you just did a short version of x.
It is a short version. When there's no a value, it's a shortened version of it. Sione, what do I do? Elias? No. What do I do? Isaac? Make each one equal 0. It's very important to remember these steps because we're going to use them later. So x plus 4 equals 0. What's x equal? X minus 6 equals 0. X equals? X cubed equals 0. X equals? 0. Some number cubed is 0. Only 0 cubed is 0. There's my answer for number 2. Holly.
Do you only make them equal to 0 when it says equal 0?
Yes.
Okay. That makes sense.
Yes.
In cases, haven't we tried to make it equal to 0 and then we went from there?
No, the last ones we just factored it and we left it factored, if you recall. We just left it at those parentheses. We didn't have equal 0 at the end.
Because the whole time now, I was like, did I forget this during the quiz?
No. No, I just asked you to factor it, which means you left it right there. All right. What happened? Splinter came out?
No, I put myself on the glass.
That was smart. Not that you did it purposely. Okay, Beatrice. Number 3, what can I factor out of everything? 3x cubed. Okay. Factored out of 3x cubed out of everything at number 3. Nicole multiplies to negative 7, adds to 6. Multiplies to negative 7, adds to 6. So it's got to be a positive and a negative number. There are only two sets of numbers, Nicole, that multiply to 7. Or sorry, only one set of numbers that multiply to 7. I can't hear you. Huh? No, it's got to multiply to the 7. Huh? That's not going to help in the future. You need to understand that and get over it. Richard. Okay, nope. Close, though. Pisha Moon? 7 and negative 1. Okay. 7 and negative 1. 7 and negative 1 will multiply to a negative 7. And 7 minus 1 is positive 6. So, Richard, you missed the fact that it's got to be a positive 6. If it was negative 7 and 1, that would get you a negative 6. That would get you a negative 6. So this one's actually going to end up being the shortest one. Set each one equal to 0. Okay, so the first one, 0. Notice when there's not plussing or adding or subtracting anything, it's just going to get that 0 every time. Okay, 1 and negative 7. Really, they just wanted, I think the people who wrote the textbooks here just wanted you to understand that we've learned how to factor it. Now we're learning how to solve it by setting them equal to 0 and finding those zeros. That's all they're doing here. Number 4. Michael, what can I factor out of each one? They all have a what? They do. What's the smallest one? 2. So I can factor out an x squared out of every single one. But I don't want a negative sign in front, so I'm actually going to factor out the negative sign as well. Negative x squared. So Michael, if I take negative x squared out of negative x to the 4th, what's left? X squared. If I take negative x squared out of positive 2x cubed, what's left? Negative 2x though, because I'm taking a negative out of a positive, it makes it change signs. Okay? Negative x squared out of 8x squared? Negative 8. Good job learning. Okay. Well, no, he applied exactly the same exact thing immediately. Riley, what multiplies to negative 8 adds to negative 2? Multiplies to negative 8 adds to negative 2. But multiplies to negative 8. Focus on that. Multiplies to negative 8. Times. Negative 4 times negative 2 makes positive 8. Negative 4 times positive 2. Good. And if I add negative 4 and positive 2, I get that negative 2. So we get x equals 0, x equals 4, and x equals negative 2. That looks like I just put 3 dots. I don't know what that meant at all.
So when you're figuring out which ones you're going to have to add to and multiply to, are you always going to multiply to?
That's what you meant, yes. You multiply to the last term and you add to the middle term. That's only if your a value is 1. In other words, there was like a 1 in front of that. If your a value is not 1, you've got to use that X box. You don't have to, but I highly recommend it.
But the one you multiply to will always have no x? Like,
Should.
problem 4, you had negative 8.
No, the mathematical answer to that is absolutely not. I'm not going to let you say that. Not, it couldn't be anything. No, the answer to that is also no.
What could it be?
All sorts of things. An infinite amount of things.
Just the last one.
It just so happens in this lesson at this level, it's going to look like that for the most part. I've tried. It's not working. I don't know why. No, they wouldn't buy me this one. I just steal it, then make them buy it. Yeah, this is a computer. People have played Fortnite on this. Yeah. Okay. Guys, we're going to be dealing with the rational root theorem. There are going to be a lot of times during this lesson, and I found, and since I did the problem, you guys once again luck out because of period 3. Since I did my example with period 3, we're going to be able to shorten it up and hopefully get a little further than we did with them. So let's look at the rational root theorem. The rational root theorem. So if you have a polynomial, so this is going back to your notes. You guys are looking at your workbooks right now. Looking back at your notes. If we have a polynomial with integer coefficients, right, and it's in the form a sub naught x to the n. You see where I'm reading? A sub naught x to the n plus a sub 1 x to the n minus 1 plus blah, 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 and we keep on going until we get a sub n, which obviously, if you look, doesn't have an x attached to it. So it's some number, right? If, big capital if it has rational roots. What are rational numbers, folks? This is chapter 1 of like every grade you've had since 7th. What are rational numbers? If you're confident enough, I don't want to hear I said that. You just didn't hear me because everybody's mumbling because nobody's confident. Numbers that aren't irrational. Huh? Whole numbers are part of the rationals. Negative rationals can be negative. Well, what defines the rationals can be written as a symbol, but still. Integers. So integers, that's positive and negative whole numbers. Ratios, which are what though? Starts with an F. Fractions. There you go. Okay. Fractions and integers, positives and negatives. Okay, those are your rationals. So as long as your polynomial only has rational coefficients, if it has any, there's a chance it has none. That's very important. Okay? If it has any rational numbers, they are always in the form, Michael, Riley, quit poking at each other. Okay? They are always in the form Q divided by P, where Q is every single factor of A sub n, and P is every single factor of A sub naught. This is a whole lot of symbols I'm throwing at you. Nothing that you can see, but it's really quite simple. All right? It's really quite simple once you see it and get the hang of it. So jumping to this example. By the way, so we're seeing here the factors of 1 through 4. 1, so that means x minus 1 is a factor. X plus 1 is a factor. 4x plus 1 was a factor. X plus 7 was a factor. X minus 1 was a factor. X is a factor. X is a factor. X minus 6 is a factor. X plus 4 is a factor. We getting that? As I'm pointing and saying? So we know what our factors are. So I'm now asking you to find them. If we can't factor it, let's find them. And the rational root theorem and synthetic division are going to help us do this. So let's somebody read it off to me. I think it's like 4x to the 5th. Okay. So if we have this, capitalized, if it has rational roots, they will be in the form of Q divided by P. Yeah, Q over P. Where Q are factors of 25, P is factors of 4. So give me, Bethany, my factors of 25. 5. Sure.
1.
Sure. 25. Guys, always remember when you find one factor, the other factor is the one that multiplies by it to get to 25, right? So if you say 1, 1 times what is 25? 25. If you say 5, 5 times what is 25? 5. So you don't have to write it twice, though. All right, P. Now that I've killed Bethany. P. All right, I guess still Bethany. 2. Factors of 4. 1. And 4. She got that out before holding cough back. Okay. So my possible rational roots are every single combination of Q divided by P. So just go in order and you won't miss any. So my Q over P, go with your first Q. My first Q is 1. My first P is, so 1 over, these are all plus or minus, 1 over 1. My first Q is 1, my second P is 2. First Q is 1, second P is 4. First Q is 5, or sorry, second Q is 5 over 1. So I'm just following that pattern. Almost ran out of room. So every possible combination, I don't have time for it today, guys. I apologize. Okay? I appreciate it, though. Sorry. If anybody really needed a positive affirmation, you are all wonderful, beautiful people and absolutely amazing, fantastic spirits. I love you all. You're going to do great things. You're fantastic, wonderful. Hallelujah. There you go. Okay? That was it. Except for Kelsey. So. All right. Any questions here? This is just, now all that gobbledygook up top when I talk about a sub naught and a sub n's and all that, right? And then factors of Q over P. Does it make more sense when we just do the example, right? So factors of Q divided by factors of P. Q is your last term. P is your first coefficient. Elias. It's just the coefficients. A sub naught is your first coefficient. A sub 1 is your second coefficient. A sub 3 is your third coefficient. It's just the number in front of your x. But that's the general form of it. Good question. All right. So if this whole thing can be factored, right? If it could be factored. By the way, how many roots does this have? This whole thing has how many roots? For sure. Has, somebody said the right number, but 5. Has 5. Why does it have 5, Bethany?
Hey, that's what I said.
Okay, I said who said it, then you stayed quiet and she said your answer. So you can't be offended by this. You can't. That's why I said you're a terrible person. The highest exponent. Thank you, Bethany. Nope. Okay. The highest exponent is 5. So this has 5 solutions. But the 5 solutions could be imaginary. They could be irrational, right? If it has rational ones, it's one of these 18 numbers. If it has rational roots, they are one of these 18 numbers. Why is it 18 numbers? You tell me.
Wait, what?
You want to go? Yeah, let's throw. Elbows. Let's go. Okay? Richard's got your back. Okay. Why is it 18? Why do I have 18 numbers on the board? Give you 5 more seconds. Michael? Switch what on them? No, you can't switch them that way. No, the order doesn't matter. No. How many numbers are here? Count.
9. It's 9.
So how many numbers are there? 9. How come why is it times 2?
Because there's 9 more numbers on top. Because they're in fraction, plus or minus.
Okay. So. All right, guys. So for all I know, example-wise, don't write this down. So at this point, I need you guys to not be writing and only focusing, because this is a trial by error, right? So for all I know, we're going to try these numbers, and they might work. And we might end up getting like x minus 1 times x plus 2 times x minus 1/2 times x plus 1/4 times x minus 25 over 4. I don't know. So it might look like this. This might be my 5, but each of these numbers will always be pulled out of here. They will always be pulled out of there. We've got to figure out which one. It's a bit of a guessing game, which is why right now it's pencils down. Because as we guess, I don't want you guys to write the wrong thing down, then be like, oh, and have to erase. You're already slow enough writing as it is. Okay? So I'm going to do synthetic, right? So I put 4, -2, 30, -15, 50, -25. Of course you did this last year.
Because I remember I didn't learn the synthetic division.
Yeah.
And you were like, if you don't know this, and I was like, oh.
Okay. No, I know. They did weird thing where they went from geometry to pre-calc to algebra 2, which is why they're here now.
Yeah.
So didn't make their life any easier. All right, so we take a guess here out of these 18 numbers. We give it a shot. It's a factor if what? We answered this last section, if you remember. It's a factor if my end result's 0. Perfect. End result is 0. So Elias, I know you're always excited to guess. Elias, pick one of these 18 numbers. Ooh. 5. You ruined it. You tainted his experiment. So Elias wants to try 5. So take a look at what happens here, folks. If they don't work, you can tell before you reach the end. You could tell before you reach the end. 5 times 4, -2. 5 times 18. That's too much. Now, maybe you don't believe it. 90 plus 30. 120 times 5. Do you think that number's going to get down to 25 anytime? We can stop and try a different number. Okay?
So do you use one of the numbers of the 6 or of the 8?
So you kind of, it's almost like hangman style. One second. It's almost hangman style. Off to the left, you're going to be like, 5 didn't work. Next number you try. 4 is not an option, Elias. 5 over 4. 5 over 4. Got you. Okay. 5 over 4. 5 over 4 times 4. The 4's cancel. We get 5. 5 minus 2 is 3. But 5 over 4 times 3 is 15 over 4. Whenever you get a fraction up here, this is a general statement. It's not 100% accurate, but for your guys' level, this will be true. If you get a fraction up here, when I go to add this, I'll have to get a common denominator. Whatever's down here is going to end up over 4. And when I multiply these, I'll get something over 16. If you get a fraction here, you probably didn't find the right number. So the second you get a fraction in this row, that's probably not it. Well, you did. So 5 over 4 didn't work. 2. 2's not an option. 1. Okay? 1. 1 times 4. 4 minus 2. 1 times 2. 30 plus 2. 1 times 32. 32. 32 minus 15. 1 times 17. And this one you had to take to the end, but it didn't make it. You know, it didn't make it. 1 didn't work. You sound so pathetic. 1/2 by Bethany. Okay. What didn't? Oh, I didn't erase it. That's weird. Okay. 1/2. 1/2 times 4. 2. -2 plus 2. 1/2 times 0. 30 plus 1/2. 30 plus 0. 30. Half of 30. There we go. I should just say it right. -15 plus 15. 0 times 1/2. 50 plus 0. Okay. Half of 50. Huh?
Yes!
Okay.
So does the last one have to equal 0?
Yes, we went over that 5 minutes ago. Okay.
And you were going to say, so can we write it down?
So we found, yes, you're going to be able to write this one down. So we found one of our solutions. Yep, there's 5. But if it didn't work the first, whatever you didn't, you're just narrowing them down. And so you don't, like this, those numbers are never going to work, so don't try them again. Okay. Riley. Yes, that's a great question. I'm going to answer that, and you actually skipped ahead in the notes. Good job on that. I'll talk about it in a second. I don't think. The syllabus? Seriously. You want credit for the syllabus assignment. You're killing Isaac. He's dying back there. He's sick, and now you're just pushing him over. You act like that's surprising. Where on earth could your syllabus be? Oh my gosh, it was in my binder. Who would have thunk? Everybody. Everybody would have thunk it.
I'm going to ask Mr. Alvarez, and I'll fill you in tomorrow. If he takes it, I'm
Stay tuned. Stay tuned. All right. Looks like everybody's done writing. Guys, when you go to do the next one, when you go to find the next one, use your depressed polynomial. Don't go back. Don't go back to using this top row. Use this row. And it makes your life easier and shorter, and you can try these numbers in this row. However, I'm going to save some time. No, none of these other numbers work. Not one. We tried for like an extra 10, 15 minutes solid in third period to try to find it. We worked through a lot of those numbers. So I'm saving you that heartache. But it's important. I probably put this example when I first typed these notes up last year. I probably put this example in to show you guys that it's okay to not have 5 solutions. You could end up saying it stops at this point. Okay? So we only have one solution, and that one solution is x equals 1/2. If you have an odd exponent, I guarantee one of these will always work. Why? Can somebody answer that question? I'd be so amazed if somebody can answer that question. If you have an odd exponent, it could be more than one, but I guarantee you one of the solutions will work if you have an odd exponent.
I thought it works.
Elias? Well, it's not guaranteed, but if you have an odd, I guarantee you one of those numbers will work. I'm actually partially lying. If somebody were listening to this as a math person, I guarantee there's at least one real solution. I can't actually guarantee that it's rational, but there's a good chance it's irrational. Yes.
You're asking why?
Yes.
It's because it can't be 0.
Hmm.
It's odd that it can't be 0.
If it was 0, it wouldn't be a polynomial. I'm talking about like if your highest exponent is odd, you're guaranteed one. Holly?
Is it because they're all divisible by a certain number?
No. So what you're finding, guys, are the zeros. What are the zeros? We talked about this like a couple of quizzes ago. You had to graph them. Where what? Zeros occur where the graph crosses the x-axis. Where the graph crosses the x-axis, and an odd one always starts on one side and ends on the other. So you have to cross it once, at least, to get to the other side of the arrow. All right. So there are no other solutions here. Now, some other cool things that you could have done. Now, we didn't try every single one, but somebody pointed out on here that we can only try negative numbers at this point because I don't have any negatives here, right? So in order to get a negative 50 here, I'd have to multiply by some negative number, right? So in order to get a negative 50 here, I'd have to multiply by some negative. So none of the positives would work at this point. That was a great observation they made. Now to answer Riley's question, and this is at the bottom of this page. Riley hit on it perfectly. If you guys go to do the next one, so let's say you put a box, you bring down that 4, okay? And you guys are trying numbers. You guys are trying numbers out. Now, like I said, nothing's going to work again. This is a hypothetical. And you're like, you know what? I didn't try a half again, and it works. And it works. If you get it twice, then you still write what are the solutions, x equals 1/2, and then you add what I wrote in bold, multiplicity, and then you put how many times it worked. So you'd say x equals 1/2 multiplicity 2, because 1/2 worked twice. Okay? Multiplicity 2. Yes, ma'am. If the solutions, no, you don't write multiplicity once. If it's just one time, you don't write multiplicity.
No, okay, so but let's say there's multiple like solutions, it's not just 1/2.
Right.
Would we have to do the multiplicities for
If any of them had to be used twice, if any of the solutions had to be used more than once, you write the multiplicity.
Okay.
So really quick here. Guys, hypothetical again, don't write this. So we got x equals 1/2. So if I were to write it in factored form, let's get, first of all, let's start getting this equal to 0. First I want to get rid of the fraction. What do I do? Multiply by 2. Get it equal to 0. What do I do? Subtract 1. So there's one of my solutions. All right. Now in this one, there will be 5 parentheses, but the other ones aren't real. But let's pretend for a second that they were real. And let's just write some fake ones. Okay. So those are all possible solutions that we might have gotten. Okay? Let's say we did them all, we found those were it. So what you'd write, Bethany, is x equals 1/2 is one of the solutions, right? X equals 1 multiplicity 2, because it happened twice. X equals 25 over 4, and x equals -5 over 2. Those would be all of my solutions. Yes. I didn't know exactly what you were asking, so I was putting that in. Okay. Time-wise, we're going to try to push further. This is enough information for you guys to do your 7-1 homework. Your 7-2 note is only 9 questions long. Okay, that'll be tomorrow, but still, I'm going to push into 7-2's lesson today because it's super similar. Super similar. So if we're given the roots, we're just working in reverse. Going backwards. That's it. So what would, if I told you the answers were 5, -2, and 3, looking at the top of your worksheet, your solutions to the top of your worksheet that you had in your workbook, sorry, look at the top of the workbook solutions, right? You had 3 answers, or 4, whatever it was, okay, each one. What would have been the step right before getting that answer? What would have been the step right before getting that answer? Sione? Close. Actually, technically, that's not what your answer looks like. Make this look like your answer. What would your answer have looked? There we go. X equals 5. Everybody okay? Sione said that's what the answer would have looked like. X equals 5, x equals -2, x equals 3. What would the step right before this have looked like? Beatrice? Get them equal to 0. Well, we're working it back till we have a polynomial. Yeah. So what would the step right before this had looked like, Raymond? It would be. Not sure? Dimitri? What do you think it would be? The next step would be. Sione? Let's do it. Perfect. And then we're going to get our final answer, which is going to take a few steps. Cameron, what do you think I'm going to do at this point? Yeah. One term, I agree. One term will be x to the third, but before that, we got to do a whole lot of stuff to get there. What are we going to do, Cameron? You do know. Pisha Moon? What are we going to do? Holly Ross. Just give me one word. Don't give me a sentence. What are we going to do?
X minus 5 is being factored out, so put it back in.
Well, how do I put back in factors? Distribute, thank you. It's the one word I'm looking for. Put the factor back in. What kind of phrase is that? Okay, distribute, yes. I like to start with the second half just so my first half stays untouched because that's easier for me. Distribute, x squared minus 3x plus 2x minus 6. Simplify, combine like terms, whatever you want to call it. And I understand I might be going a little fast because this is something you know how to do. And I distribute again. Cameron, does that make sense? Now I get my x cubed, like she was talking about. And I combine like terms. And I'll give you guys a pause so that way you can write, copy, figure it out. Whoa, gal. Her. It's a cough off. Who's going to win? Isaac or Bethany? Bethany already won?
All day. All week.
You lost, Isaac. How do you feel about that? Okay. He's very gracious. Well, you got to make him feel bad. While I'm paused, I will ask, are there questions as to what I did? I think we know how to distribute and combine like terms. Though? Elias. I didn't divide anything. What 2? I did negative 3x plus 2x is negative 1x. Gabriela. I thought you had your hand up while I was answering Elias. Bethany.
You always start with your back 2 terms?
I like to, just because of the fact that it's easier for me to distribute from left to right. Not for any good reasons other than habit. Not because you can't distribute the other way. How was your workout yesterday? No, at home, after school. Yeah. Oh yeah? I was walking to my car and I could hear those plates clanking together. I looked over, the garage door was open. I was like, "Yep, there are the Alfaros, working out." He just had Mariah Carey, "All I Want for Christmas Is You" on blast, repeat play. That's what he.
That would give me a pump because I'd be like, turn it off.
Okay. Any questions? We're going to start but not finish the next one. Take a look at 7-2 as well. Get as much as you can done, folks, because I am going to push us to finish 7-2 tomorrow. And then whatever we get through, the rest of the day will be work day for 7-1 and 7-2. That also is going to function as your review for a quick 3-question quiz on Friday. What are you doing? I said, let's do the next example. We're only going to start it. Okay? We got a full 5 minutes left. No, because we only have a full 5 minutes, so unfortunately I won't be able to jump around the class.
Why do problems take so long now?
Okay. Guys, this is the same thing, but realize how many roots do I have written? Somebody give me the correct answer.
6.
5 is correct, Michael. Thank you. Okay. 2, 4, 5. Okay. 2, 4, 5. All right, so I've got x plus square root 2 times x minus square root 2 times x plus 3i times x minus 3i times x minus 1. You already won, Bethany. Quit just rubbing it in his face now. It is an imaginary 3. Because irrational numbers and imaginary numbers always come in pairs. Imaginary and irrational numbers always come in pairs. Always. All right. Guys, it follows here. These are conjugates, which means they won't have a middle term, but third period didn't believe me, so unfortunately we'll do the whole thing. Okay? X times x is x squared. X times negative square root 2. Positive square root 2 times x. Guys, square root 2 times negative square root 2. I need everybody to think about this and believe it when the answer is given. Positive square root 2 times negative square root 2.
0. Nothing. Negative square root 4.
What's the square root of 4, though, Kelsey?
Whoa, what the?
Oop. My apologies, Kelsey. Positive square root 2 times negative square root 2. A positive times a negative makes a negative, right, folks? And square root 2 times square root 2 makes square root 4. But the square root of 4 is 2. Sione. Well, because now I've got that. Here, x times x. X times negative 3i. 3i times x. Positive 3i times negative 3i. Negative 9i squared. X minus 1. Hey, I don't like going through it any more than you guys, but I would have taken massive shortcuts that you should be familiar with. Elias. I know, and I told that to third period, and I tried jumping to what would have been my next step, and they were like, wait a minute, where did it go? No. What is I squared, folks? What is I squared? Not 1. Negative 1. What's negative 9 times negative 1? Positive 9. All right. We're going to stop after I write this step. I tried jumping straight to that with third period. They made me write that out. And it's a groan, but it was unnecessary. All right. We'll continue tomorrow. Please do 7-1 homework. Workbook, take a look at it. Try to do a couple of 7-2s that look like this. It'll really save you time and make you more ready for the quiz Friday.
Mr. Bates?
Yes, ma'am.